Hello there, gentlemen. We're going to take a look at really the last new piece of information you guys are going to learn about in AP Pure Science, and it's really the last thing that you need to know for the exam. I mean, there's a lot of other stuff we can do. For your example, your project, you have to do some stuff with files, and there's a whole lot of other things. But for the AP Pure Science exam, this is the last piece of the puzzle that you guys need to know. And we're going to be talking about class hierarchies and interfaces right now. And you guys have we've talked about classes before. So we have, you have to understand hierarchies and polymorphism. That's what we're trying to do here. We're going to learn about abstract classes, learn the syntax for calling superclass constructors and methods, and then you have to understand interfaces. That's your goal. This is what we really need to know for that AP exam. All right, so here we go. We have a superclass, which is called your base class, and then you have a subclass, which is derived from the superclass. And the way you write it is you say the subclass extends the superclass. All right. The other piece in here is something called inheritance, right? So the subclass inherits the properties of the superclass. And the way you can tell an inheritance is happening is they have something called an is-a-has-a relationship. So an inheritance is represented by an is-a relationship between objects, right? So for example, if I say a truck is an automobile, a car is an automobile, right? A car is a type of automobile, a truck is a type of automobile. So if I had an automobile class and a truck class, then a truck would inherit the properties of the automobile class. So therefore it would be an inheritance relationship. But on the other hand, I might say a car has a car door, and a truck has a car door, and a truck has an engine, and a car has an engine, right? An engine or a car door might be an object itself, and just because a truck has a car door doesn't mean a truck is a type of car. So there is no inheritance at that level. Same thing with the engine. So it's called is-a-has-a. Remember, I and I, right? Is-a and inheritance go together. So when you're on the AP exam and they ask you a situation, is there inheritance here? Just think about, is this a type of something else? If that is the case, then it's an inheritance relationship. It means we have a superclass, subclass relationship going on here. All right, so we talk about class hierarchy then. So we're using inheritance. Programmer can define a class of hierarchy of classes. We really didn't get into this year. I've done it in the past, early on in the book. We had an object called a balloon, and then underneath the balloon, we actually created something called a round balloon, which extended the balloon, which the round balloon inherited the properties of a balloon. And then we had one called a square balloon that inherited the properties of a balloon, and another one called a fancy balloon, which inherited the properties of a balloon, where it made like kind of zigzaggy star-shaped balloons. And then we have what's called a birthday balloon and a hot air balloon. We're going to take a look at birthday balloon a little bit today, which extends round balloon and hot air balloon. So in other words, birthday balloon has the properties of a round balloon, which has properties of a balloon. So it kind of inherits it down the line. All right, so what's the purpose of this hierarchy? It tells you here, it's to help reduce duplication of code by factoring out common code from similar classes into a common superclass. So for example, here's my balloon class up here. It has constructors in it, and it has accessors in it, right? You know, like get and set methods and things like that. And they also have a method here called distance. They have a method called move. They have another method called set radius. They have another one is inside, is on the border, and draw, right? So distance is simply a helper method to find the distance maybe across the balloon. The move method, if I need to move the location of the balloon based off its x and y coordinates. You also have the set radius method, which sets the size of the balloon, and so forth. And then the draw actually draws the balloon up on the screen. So if I have a round balloon, it has a constructor, just like the balloon class has a constructor, and then it also has a draw method, and the draw method actually redefines the draw right here. And we've done that before with the two-string method, where we can just inherit the draw method down if we want to, or we could redefine it. And that's what we're going to do in round balloon. It's the same deal in oval balloon. They have a constructor, but they have to redefine distance, because an oval does not have the same distance like a radius on a circle would. So you have to redefine the distance for the oval balloon, and then you have to redefine your draw to be able to draw the shape as an oval. So if we look at this then, here's an example right now to reduce the duplication of code, right? So I have a method inside here called add, right? And what I'm doing is I'm going to pass in an object defined as a balloon, right? So I'm passing in balloon to it, and I'm naming it B. Now I have a program called balloons, and it has an add method in it, right? So I can say balloons.add B, right? And what that is going to do is that actually it's just going to go out and call, I'm going to make my own add method that calls the previous balloons method above me. and runs its add method. Right, same deal over here. Like we have the add for round balloon. I can pass a round balloon in, and I can just pass it up to the balloon level above me and let it run its add method. And the same deal with the oval balloon. Remember, oval balloon was a type of balloon, so I can simply call its add method up above it and have it pass in as well. So it actually saves a little bit of time. And I'll show you an example of that later on. So then we have something called abstract classes. So it says some of the methods in a class can be declared abstract and left with only signatures defined. A class with one or more abstract method must be declared as abstract. So for example, this actual balloon class at the very top was actually an abstract class, because inside there they could say, if I say public abstract void draw, and then I'm going to pass in a graphics object and a Boolean object in here, Boolean variable in it, then what this says, I'm actually not defining draw in here. I'm saying anybody that inherits me, that inherits the balloon object, has to have a method called draw that takes in a graphics and a Boolean. So this now makes this, because I've added one abstract method in here, it now makes my class abstract. And then that actually plays out a little bit different. We'll talk about it here soon. So abstract classes serve as common superclasses for more specific classes. Abstract methods provide an opportunity for the compiler to do additional error checking. And abstract classes are closer to the root of the hierarchy, since they describe more abstract objects, right? So again, same deal. Maybe I want to build something that's going to grow on down the line, so I define some abstract methods in it, and I say you have to define them later on. So for example, here's kind of like the tree of objects right now. At the very top, we have everything in Java as an object. And then there's a branch going off over here. There's branches everywhere. Well, off of this branch, they have something called a component, right? And they're telling us anything that is a abstract class, they have a red box around. So there's a component abstract class that comes off of object. That is an abstract class because it has some abstract methods in it. But inside a component, it has, button extends component, text component extends component, and container extends component. These are all concrete classes. They actually have everything defined. So I can call something a button object. I can call something a text component object, and so forth. But then they took container and they went down, and container has JComponent, which extends container, but it adds an additional abstract class in it. And then from JComponent, we have a concrete JComponent called a JPanel. So again, a JPanel is a type of JComponent, which is a type container, which is a type component, which is a type object. You can see that it just keeps inheriting down the line. But then abstract button itself right here is an abstract class, which comes from our JComponents. But then underneath it, we have JMenuItem, JButton, a bunch of other things underneath there. So we can just kind of create this huge tree and save ourselves a whole lot of coding by passing things down. Again, this is really no different than, like as a human beings, like in genetics, right? You got your mom and your dad, and they're passing down their genetics, and it just keeps passing down the line. So Java does not allow us to instantiate or create objects of abstract classes. I mentioned that before. An abstract class can have constructors. They can be called from constructors of subclasses. And a class with no abstract methods is called concrete. So when we come back to here, this is an abstract class because it has an abstract method in it, but these are concrete classes. These are concrete classes here because everything has been fully defined out. So I cannot instantiate an object of type component, but I can instantiate each one of these. But we can set up variables, and you'll see here in a second what I mean by that. So in Java, every class by default extends the library class object. We've talked about this before. Object itself is a concrete class, and here's three methods that are inside of it. There's a couple others that are in there. There's the toString method, which returns a type string. We've messed with this. Remember, if we if we actually try to output an object, it puts out on the screen something like the name of the object and then its memory location, right? Because that's what object does based off the toString. But we can override that and make our own toString. There's an equals operator that compares objects against each other, see if they're equals. Again, we can override that and make our own. There's another one called a hash code, and there's some other ones out there as well. If I want to invoke a superclass as constructors, right? So we have this birthday balloon, which is of type round balloon. So we simply say public class birthday balloon extends round balloon. So that pulls all of his properties down into birthday balloon. I have a constructor in here called birthday balloon. It takes in three integers, right? X and Y and R, right? Probably the X and Y coordinate of the balloon where it's going to be on the screen, the radius of it. then a color object called C, and then an age variable that's of type integer. What they're going to do is birthday balloon, remember, is a type round balloon, so they're just going to call its constructor from above. The round balloon class has a constructor that takes in these four variables, x, y, and r, and then the color variable. So I'm just going to call the super guy. It's going to set those variables for me based off the ones I passed in, so I don't need to rewrite all that code. I just got to put one line of code. And then I'm just going to add the component that I need, which is age. So I say this.age says in this class, not the super one, go to this class and set my age and this one equal to age. You could honestly do this and just say age equals age right here. It's not a really good practice to do. So if you say this.age, it references the variables, the fields that are up inside of this class. I probably would have maybe made this A instead of age and been less ambiguous too. All right. Also, it does mention down here, if you're calling the super constructor, it needs to be the first thing in the line right here. All right. And then again, it has to match. So if there's not a constructor that has four variables in it, it's not going to work. Or if they don't, if it's like two integers and two colors, that wouldn't work because these are three integers and a color. So you got to make sure they match up exactly. One of the superclass constructors is always called, but you don't have to explicitly call super statement. So if there is no explicit call to super, then the superclass's no argument constructor is called by default. So if I don't create a constructor, it's just automatically going to go up the line and grab the constructor above it, and so forth on down the line. And here's an example right here. So we talk about like birthday balloon is of type round balloon, and round balloon is of type balloon, and balloon is of type object. So if I don't define a constructor here, it's going to call this guy's constructor, his default constructor. If I don't have a default constructor here, it's going to go up and call this one. If I don't want it here, it's going to go up and call this one. So it's just going to keep running up the line to the supers. I don't have to put in super open and close parentheses. It will automatically do that for me. If I want to call my superclasses methods, right? So I got birthday balloon now, right? I have extended round balloon, and I want to call the methods that are up inside of here. Then I have to use a super command. So for example, my draw, we had earlier, we said in the, let's see, here it is, we have public abstract void draw. They have an abstract method called draw that requires you to pass in a graphics variable and a boolean variable, right? And when we call down here, we're actually creating our birthday balloon. We're actually creating a draw method here, which takes in a graphics variable and a boolean called make it filled, whether I'm going to fill it or not. So, but for birthday balloon, I'm going to set my font. So we have something called an age font that was probably some kind of private field up above that based off of the age of the user, they get a different font. And then we're going to call super.draw. We're going to call the draw method from round balloon. And I'm going to utilize it with the G make it filled. So rather than rewrite all that code for that, I'm just going to utilize his code. And then after that, I'm going to go and set my color to black, and then I'm going to put a draw string in there, which is going to allow me to actually write in the middle of the balloon, and I'm going to actually be able to print the age and specify the location where it's going to be. So there it is. I can actually, again, I can cut out, let's say there's like 6 lines of code inside of my draw method up above. I just saved myself 5 lines of code by calling the .draw command. So super dot calls are often used in subclasses of library classes. So for example, we have, there's a class called a canvas, which extends a JPanel, which we saw in that tree before. And then inside of it, they have a method called paint component, which takes in a graphic variable. So rather than write all the code again, I just say super.paint component, which is going to go up to the canvas class and pull its paint component out of it. All right, so now here's this big fancy word called polymorphism. This is something you're going to need to know for that exam. So polymorphism ensures that the correct method is called for an object of a specific type, even when that object is disguised as a reference to a more generic type. That is the type of the object's superclass or some ancestor higher up the inheritance line. Okay, that's a whole lot of words. It doesn't make a lot of sense. So this is saying I can generically define a generic type, right? Remember we had the balloon class. I can set up a variable called a balloon, but link balloon to round balloons and birthday balloons and square balloons. And polymorphism will make sure that I use the appropriate classes. And this will make a little more sense here when we actually start to see it. So they tell you once you define a common superclass, polymorphism just takes place. You don't need to do anything special. It just happens for you. Java does a nice job on it. All right, so let's take a look at this guy, this paint component, right? So we made this paint component method that was part of our J panel, which was part of Canvas, I believe, right? So I call my super.paint component G, right? And this is actually kind of cool. And then inside of here, I'm creating a for each command, right? So I'm going to make this loop that's going to create this variable B, which is of type balloon, right? Which is our most generic class at the very top. And I'm going to loop through balloons, which looks to be probably a linked an array list, and then inside of here. So it's really cool. It's actually probably an array list of balloons. And maybe in position 0 it has a round balloon. In position 1 it has a square balloon. In position 2 it has a square balloon. In position 3 it has a birthday balloon. In position 4 it has a fancy balloon, so forth. What's really cool is I can define this as generically as a B because they're all type balloon, but then link it to the actual real object of it. So remember I told you before, you can't instantiate a balloon object, but I can create a balloon variable and link it to a different balloon object. So then what's really cool is now when I say b.draw, if b at this moment is pointing towards a round balloon, it runs a round balloons command. If b is pointing at a fancy balloon, it runs a fancy balloons draw command. So you don't have to think through it. It will automatically do that. And that's one of the advantages of using this really high level and creating the tree structure down below. All right, so we've been talking about abstract classes and inheritance here. Now we're going to talk about something called interfaces, right? So an interface, we often think of an interface as like a screen is an interface, and a keyboard is an interface, and a mouse is an interface, right? It's a way that we communicate, and it's kind of similar in a roundabout way. But in a computer world, though, the term interface refers to any mechanism that connects two devices or entities and defines the rules for their interaction. So a mouse does connect myself and my computer, and the mouse defines how I can interact with the computer, and the keyboard defines how I can, right? Those interfaces define how I can interact with these devices. Well, in programming, I can have, let's say, an object over here, a chess object, a checkers object. There was this one called Chomp, which we didn't do. It was out of an earlier chapter. It's a game. These are all objects, and I can have a computer player and a human player, which are objects, but I can have what's called a player interface. And a player interface is what allows these two to communicate with each other seamlessly. The checkers know via the player interface that both of these objects will have the right way to communicate back and forth. So an interface in Java is like an abstract class, but it does not have any fields or constructors, and all of its methods are abstract. So it is not concrete in any way whatsoever. There are no fully defined methods or anything in there. So look at this here. It says public interface strategy. And inside of here it says you have to make a method called find best move that takes in a game of type chomp game, and it returns a location. And I have another one called find random move, which takes in a game of type chomp game, and it returns a location. So what this is saying is if you implement my strategy, you have to make these two methods. You have to see, notice how they just have semicolons, they don't have curly braces. So they're just saying you have to make this method and this method. So they're like abstract methods. Right? But everything in the strategy is abstract. Notice how the word abstract is not in there? Because it's automatically publicly abstract. I didn't have to put the word public in front of these as well. Now we must officially state that a class implements an interface. Okay, so before we said we extend an object, down here I'm going to implement. So when I say public class waltz implements dance, and that means that my waltz class has to actually create the methods that dance said that I had to create. So again, it says here, a concrete class that implements an interface must apply all the methods of that interface. So here's three methods inside this waltz class right now. One's called getName, which returns a type string, right? And you can see it right there. So they probably defined these three methods inside the dance interface. You have to have a getName, a getSteps, and a getBeat. And getName returns a string, and getSteps takes in an integer but returns a string, and getBeat returns an integer array. Right? And they're just not showing you the code that's going on inside those right now, but you get the idea. These three, because they were in the dance interface, has to be defined inside the waltz class. So a class can implement several interfaces. Like an abstract class, an interface supplies secondary data type to objects of a class that implements that interface. Actually, let me step back to this one. A class can implement several interfaces. So it's kind of like you inherit the properties of mom and dad. You can actually implement two things at the same time. So imagine if we had an object that was called a square. A square is really a rhombus, and a square is a rectangle. So we could make a rectangle interface and a rhombus interface, and a square can actually implement both of those because they have the same properties from both of those. And you'll see more examples here. Maybe down here with the waltz, maybe waltz, we have it implementing a dance, but maybe there's a music called waltz music, right? So I can have a music interface. So I can make a waltz object that implements a dance and a music interface. All right, so it says you can also declare a variable and parameters of an interface type. So for example, I can say dance D, right? I can make D of type interface, but I can't say equals new dance because I can't instantiate it. It is abstract. So I have to say dance D equals new waltz, dance D equals new mambo, dance D equals new jitterbug, right? It has to implement concrete objects, but you cannot instantiate a dance. And then polymorphism fully applies to object disguises interface types as well. So that same concept that we had before. So here's an example right now. I have this interface called edible. And I'm telling you, if you implement my edible interface, you have to make a method called getFoodGroup, which returns a string, and you have to make a method called getCaloriesPerServing, which turns an integer. So over here, they made this class called public class pancake. It implements edible. It's got variables and other stuff inside there and methods, but you know for sure it has these two methods in there. So now down here in my program, public class breakfast, I set up a variable called my total calories at 0. I'm going to call a method called eat. And I'm going to say I'm going to pass a pancake and 4. I'm going to eat 4 servings of pancakes. Well, again, I created the object. I created it as an OBJ, right, as an edible interface. But remember, I'm going to pass actually a pancake object into it. So it's going to inherit it's going to use polymorphism to know that when I call a method from OBJ, so when I say obj.getCaloriesPerServing, it's actually going to get the getCaloriesPerServing from pancake, not the getCaloriesPerServing from hot dog or not from pizza. It gets the one from the one that I'm actually using at that time. So it's really cool then. So I can say I passed in pancakes and 4. So it's going to take my getCaloriesPerServing for pancake, and it's going to multiply it by 4 and get my calories and add it to my calories. And now I can pass in a pizza next and do 2 and do the same thing. And I pass hot dogs and so forth on down the line. So it makes this very flexible. OBJ becomes very flexible. It can point to a whole bunch of different types of objects that are all related to each other. Right, so let's take a look at, so again, the classes versus interfaces, right? So here's some similarities. The superclass provides a secondary data type to objects of its subclasses, right? So superclass, the subclasses are going to pull down all the data types from a superclass. An interface provides a secondary data type to objects of classes that implement the interface, right? So again, same deal, the pancake pulled down the properties of the edible. An abstract class cannot be instantiated, and an interface cannot be instantiated. So those are all similarities. A concrete subclass of an abstract class must define all inherited abstract methods. So anything I say it's an abstract in an abstract class has to be inside the concrete class. A concrete class that implements an interface must define all the methods specified by the interface, identical. A class can extend another class. A subclass can add methods and override some of its superclass methods. So I can extend my superclass and add additional things to it or override existing ones. Same deal with an interface. I can extend another interface called a superinterface by adding declarations of abstract methods. So, and that is possible. I mean, you can just make this interface that has multiple interfaces in it. It's not very common. So here's some differences. A class can extend only one class. So I can't say I can't have a rectangle class and a rhombus class and make a square class extend both of those. I can only do that with interfaces. That's where it says over here, a class can implement any number of interfaces. A class can have fields. An interface cannot have fields. The only exception is if you did a final constant. If you made a constant, public static final constant, you could put that in an interface. A class defines its own constructor or gets a default constructor from above it. Interface has no constructors whatsoever. A concrete class has all of its methods defined. An abstract class usually has one or more abstract methods. All methods declared in interface are abstract. Okay? So concrete, everything's defined. Abstract usually has at least one abstract, but everything in an interface is abstract. And every class is a part of a hierarchy of classes with an object at the top. An interface may belong to a small hierarchy of interfaces, but that is not very, very common at all. All right, so now review. And this is actually where you guys have some work. I'm going to put an assignment out there, and I'm going to put a text box. You're going to have to answer these questions. So for number 1, it says describe 2 ways for eliminating duplicate code using class hierarchies. Number 2, what is an abstract class? Number 3, why is it better to use an abstract method rather than an empty method? Number 4, you got to define a concrete class. Number 5, what happens when a constructor of a subclass does not have a superstatement? Is a superclass's constructor called? Number 6, can an abstract class be instantiated? Number 7, can some method 1 have a call super.someMethod 2? Number 8, what happens if by mistake a programmer puts in his paint component a method called a paint component G instead of super.paintComponentG? Number 9, what is the main difference between an abstract class and an interface? Number 10, can a class implement several interfaces? Number 11, suppose you declare a variable of an interface type. What type of value can be assigned to that variable? And number 12, what is the main advantage of interfaces over abstract classes? Actually, I'm not going to do it as a text box. I'm going to put this out there. You guys need to type these up into a Word document and need to answer these in a Word document, and I'm going to have you upload those into Canvas. All right, I hope this helps. Shoot me messages. If I set up some office hours, make sure you pop in. All right, you guys have a great night.